So yeah, my name is Tom. I'm a senior applications engineer here at Shure UK, covering most of mainland Europe, specifically in this, lots of audio in the other areas too.
Hi everybody, my name's Andrew. I work at Shure UK. I look after the customers in the systems vertical, so with a primary focus on our MXA product range for corporate boardrooms, as well as some of the wireless technology that we're going to be talking about today.
Yeah, so onto that, we're going to look at some of the audio solutions for effortless communication, focusing specifically on the world of corporate wireless, because it can be a bit of a minefield for those who are brand new to it altogether. So we're going to cover off firstly, when are wireless microphones needed in a corporate environment? Also then the basic features of a wireless microphone system, how then you might begin to select your wireless system. And lastly, we've got some case studies for you to look at so you can get a bit of an idea of which systems worked for different customers in different applications. So in a corporate environment, when might you need wireless? Well, one good option is like in a larger lecture theatre style. You might have a larger town hall that gets used every, say, month or quarter to address a large group of people, or it could be in a lecture theatre in a university or something like that, like a one-to-many situation in a kind of traditional presentatory style.
Another use for your wireless microphones could be in a video conferencing application, because if you're trying to communicate with somebody over a video link, they're obviously going to need to hear you. So you obviously need a camera for your video feed, and you're going to need some wireless microphones, maybe for a table like this that you see in the picture here, because some of these high-end pieces of furniture might not go down quite so well if you drill holes into the table to put static microphones. So wireless ones that can be put away at the end of the day is definitely a good idea.
Agreed. IKEA tables are fine.
Yeah, you can drill holes in those.
Another example is in some kind of presentation situation like this, particularly for training. The other thing you might notice for this application is that all the tables will be somewhat movable. So for applications where you can move the tables around and you don't always know where you're going to need the microphones, having them to be wireless is a very, very good option indeed.
And finally, maybe you're in a proper broadcast scenario where you've got a full production rig, you're doing your product launch, or you're giving your financial results to your investors, and you really want to deliver a good TV broadcast style presentation. A fixed microphone on a lectern maybe isn't going to suit quite so well. So a lapel on your shirt or your jacket would be useful, so you can wander about your stage, you can make your presentation look dynamic and engaging, and the wireless mic is on you in the correct position at all times.
Yeah, perfect. Again, another little training example here, but this time the presenter is moving about through the room, as you can see. So lots of different examples here for people to use their wireless microphones. So how do they work? Over to you, Mr. Francis.
All right, so there are really three key components of a wireless microphone system, and I'm going to show you and talk to you through that right now. The first part is the microphone itself. So on our graphic here, we can see at the top of our handheld transmitter, we have the little section at the top, which is the microphone. In a lot of our products, that's interchangeable. So you may like the sound of an SM58. You equally might prefer the sound of a Beta 87. It doesn't actually matter, because the sound that comes out of that capsule into the wireless transmitter is what's picked up. So you find something that you like the sound of, and then you transmit it wirelessly, which is the second part of our piece of hardware here, the transmitter. So you will need a system-specific transmitter, because you'll find out later on that we have different products which work in slightly different ways. But ultimately, the transmitter takes that audio from the capsule, turns it into radio frequencies, and transmits it
by magic
through the air to a receiver. But as our other graphic here shows, you can have different form factors for your wireless microphone system here. So your headset mic represents the microphone, and the body pack represents the transmitter in two separate components, whereas the handheld is one complete unit. Okay. Two other examples of wireless transmitters, same idea. These are both integrated like your handheld. They are a capsule and a transmitter in one physical unit. Now, the other part of this puzzle is the receiver. So when you're transmitting your radio frequencies, which have got your audio data embedded into it, you need to receive that and then turn it back into an audio signal again. And this process happens in your wireless receiver. And you have one transmitter paired with one receiver on a given frequency, which we'll talk a little bit more about later on. And this really for us is one wireless channel, one wireless microphone system.
So a channel is really a combination of a transmitter and a receiver paired up, or
Yes.
a receive channel specifically.
Correct.
Gotcha.
What you can't do with these products is take two transmitters and hope to receive those two different audio signals in that one receiver. It really is a 1-to-1 ratio, transmitter to receiver. So sadly, this is not going to work. If you did have a need to require two transmitters, you will need two receivers. So this is a 2-channel wireless system.
Yeah, the combination of the two channels together makes it a system. Gotcha.
Yeah. If we want a third one on a body pack, we need a third system, and so on and so on. And we keep scaling the components up to the number of channels we wish to use concurrently at the same time. Now, in some of our products, you can get a single physical receive unit, which can receive 4 channels of transmit audio. So this is a quad channel receiver. So you have 5 components making up a 4-channel wireless system. But it's the same idea, one transmit channel to one receive channel. It's just the receivers have been put together on one piece of component. And here we can see we've got some wireless antenna. So instead of having the receive channels in a rack somewhere, all the RF energy from these transmitters goes out into the environment. They're picked up by one receiver and then again split out at the receiver. The actual physical receive unit.
So sometimes the receiver physically could have 1 receive channel, 2 receive channels, 4 receive channels, or 8 receive channels,
yep,
depending on the system which it is.
Yep. And all these transmitters are on their single frequency, pushing out their data into the RF environment, and they are all collated at the receiver and then split out again at the receiver. So this is an antenna. And some other additional components which make your system maybe a little bit easier to manage. We've got charging stations. So with the rechargeable batteries, you don't need to be putting in single-use batteries anymore. You can just put them in their charging dock so that whenever you need to use them, you take them off their charging dock and they're ready to go. That can be a 2, a 4, or an 8-channel variant. And some other key features that we offer in our wireless system is encryption over the air. So if you're turning up to an event where you're hoping to receive the audio from a system which you're not really part of, you can't do that. So if you were a journalist trying to listen into a press launch of a company, you couldn't just turn up with a receiver, tune it to the same frequency and hope to hear that audio, because the transmit between the transmitter and the receiver is encrypted.
So if I'm the CEO of a large company and I wanted to present to my large audience, probably on a webinar as well these days,
yep,
it means that I could encrypt that wireless signal to make sure that only my nominated receiver can receive that audio.
Correct.
And that other people can't tune in the way that you tune into a radio station in your car.
Yes, it's not a one-to-many broadcast, it is a one-to-one broadcast which is secured by an encryption key.
So let's have a look at how these things actually work and how much space they take up in the real world. Here we have a very beautifully drawn office building, and in here we're going to have a wireless microphone. Now, these take up some spectrum, or some kind of invisible electromagnetic spectrum, which is the same as visible light, but at a much lower frequency than visible light. And they take up some physical space, but just we can't really see or comprehend what they're doing. So here we have a wireless microphone, and it might broadcast a bubble, or like a beach ball of space around it. So it's going to take up that amount of space for a given
electromagnetic energy.
That's right, yeah.
Just radiating from that transmitter.
Yeah, so long as your receiver is within that blue sphere, you will be able to receive that signal. If you go too far away, you miss the signal or you drop out. Or you could have a much more powerful transmitter that covers a larger area, but that will eat into your battery life quite quickly. Multiple microphones take up multiple bits of spectrum, so they'll all cover that same large area, but you tune them onto different frequencies. It's a bit like how I'm in this physical space here and Andrew's in that physical space there, but you'd still hear us both within the same, I don't know, 10, 15 meter perimeter from where we are right now. Of course, you guys are on a webinar, so you can hear us hundreds of miles away, but that's by the by. Again, we have a third microphone towards the right-hand edge of our system here. There's even stacks in the same way when you've got larger office buildings too. See, we could have one at the top of the square building in the middle. This is London, of course. Another one over here, another one here. So all of these bubbles of wireless microphones need their own physical space. If there's enough physical space between wireless microphones, you can start to overlap on frequency. So, for example, Andrew and I could have private conversations, but would have to be far enough away so that my natural voice doesn't interfere with Andrew's. But if two people talk at the same time, it gets pretty hard to hear. So you can see how quite quickly you end up with a lot of spectrum being used in a very, very busy space indeed. So let's knuckle down a little bit into the world of spectrum directly. So I'm going to read these ones out. Spectrum is basically a national resource, and there's a very, very high demand on it, particularly in the last 10, 15 years or so. And there's been a large change in how the spectrum is managed and regulated. Like I mentioned, it's a bit like real estate. Right now in this room, I'm taking up this amount of space, and I need this amount of space in order to operate. If I was to start dancing or whatever, I'd need a bit more space, hence the need to spread out.
From a real estate point of view, it's like stacking towers on Manhattan versus estates in a country field.
That's correct. Yeah. I'm not going to go into this in too much detail, but basically we run the whole thing in the megahertz range, and these are the bands or chunks, if you like, of spectrum that we have available to us. It's a bit like areas of a building where you're permitted to go versus areas of a building you're not permitted to go. So these are the areas. Some of them have certain characteristics which make them better for some applications, and other pieces of spectrum are better for other applications, but we'll come into that in just a moment. The ones we use for our corporate mics that we have set up behind us are the UHF band in the middle, as well as the DECT band, and we'll come into those in a bit more detail when we start to run through our products directly.
A lot of governments across the world have really started to realize that this electromagnetic spectrum is a valuable resource, and as such, they can regulate it and charge you for the use. But there are certain areas within that large, broad spectrum that we saw there, Tom, that you can use for free. But as you might expect, it's actually only a small chunk of it. So channel 70 is 2 megahertz wide, which is quite high up the 800 megahertz range. This used to be where radio microphones were much more easily available to use up until 4G networking became a real life technological achievement. But now we have bits below 863, which is part of the mobile phone usage, and we have more above 865. So there is that tiny little gap of unused spectrum in the middle, which we can use 1, maybe 2, 4 maximum, would you say, radio mics. And if you're using that, you can use that for free. Also, in the DECT band, this 1.8 to 1.93 gigahertz, this is also a globally accepted free-to-use area of spectrum, because traditionally it was for the use of wireless home telephones. So, you know, back in the 70s or 80s, where you'd have your massive phone with a really big long antenna that you could wander around your house in, that would be using the DECT band. And then finally, you've got Wi-Fi, and I think everybody is quite familiar with what Wi-Fi is these days, but 2.4 and 5 gigahertz is free to use globally, and you can use radio microphones in that spectrum, but we won't be covering that today, mostly because it's not that suitable for the corporate environment.
Correct.
In the UK, we have some chargeable licenses. So these are purchased either on an annual or on a per event basis from Ofcom, which is the national regulator. So we have channel 38, which operates in the 606 to 614 area with kind of half a megahertz at each end as a guard band. And we've got that 823 to 832 and also 1785 to 1805 is all covered under this channel 38 license. There are some advantages to this in that you can buy a channel 38 license and you can go anywhere in the UK and use it legally, but anybody who has that channel 38 license can use that area legally. So you don't necessarily have any protection around your radio mic usage versus somebody else's in the same space on the same day.
But also, if I'm buying radio mics for an office space, for example, I'm more likely to need it to be more secure in one location.
Yes, if you're only using radio mics in one location, then you can apply for a per day or a per year access to a designated bit of spectrum within this 470 to 694 range. And that does give you a bit of legal protection around, I'm allowed to use my radio mic on this frequency and nobody else is, because I've paid for the license.
I think one thing to mention as well, these are just the way it works in the UK, for an example. However, lots of other countries, some do have licensing regulations and some are much less strict as well.
Yep.
You can contact us by email to figure out which are the ones that work in for your country.
So how should I select the best wireless system for my needs? Because as Tom rightly pointed out, we have a fair few to choose from. And so we need to look at some advantages and maybe disadvantages of certain systems and really navigate to figure out what's going to happen.
It's a bit like saying, I need to have a vehicle.
Yeah.
Like, cool. Your vehicle can be a bike. It could be a motorbike,
Yep.
a car or a boat or whatever. They're all vehicles, but they're suited to particular applications. So within the world of wireless mics, we need to figure out which is best honed and
Yep.
suited to us directly.
And we've narrowed this down into 4 main topics of consideration. So the first one
Go back.
is the channel count. So this is a calculation of how many microphones you wish to use at the same time in your location. However, there are some additional factors to take into consideration. So how many rooms times how many channels, it gives you your total channel count that you want to use in your system. However, the total number on air in use at the same time may be slightly less than that. So you might be buying 8 radio mics, but you know that you only need to use 4 at any given time. And then we need to think about how close those wireless transmitters are to each other, because if you're buying 8 and you're using 4 on the top floor of a building, channel, maybe floor 50, and another floor in the basement, then those really could be considered 2 4-channel systems, because you could equally operate those on the same frequency because they're far enough away.
Okay, so if there's enough separation between systems, you can start to consider them as individual systems.
Yes.
Rather than one large 8
Yep.
channel system.
So the closer the proximity, you need to consider it as 8 channels on air versus having 4 on air at the same time at distance.
Gotcha.
And then finally, this is often overlooked, is there any other existing wireless in your location which you need to share your spectrum with? Because it's all very well saying, oh, well, I know that my company doesn't own any radio mics at the moment, so we can buy and use whatever we want. But you may find that the company above you is using lots, the company below you is using lots, and all of a sudden you need to think about sharing that space a lot more considerately.
Thank you. So the next thing we'll look at is the way these wireless microphones are actually used on a daily basis. So the first topic is the self-service topic. And here is like, well, does the end user set the room up for themselves? Like, would I, as a person in a large corporate environment, be required to go into the training room and be able to set up my wireless mic itself? How much interaction do I need to have, or am I expected rather to have, with the hardware itself directly? Because depending on the system you have, there are some that are more involved and others that are less involved. And there are, of course, pros and cons for each of those systems. Or you could have someone like me or Andrew who work for your corporation on site to come in and set the system up. For example, before a large meeting, I might come in and place or make sure all the microphones are charged up, ready to go, and then placed on the table, all passing audio. So all the end user has to do is sit down and present or talk or train or teach.
Yep.
Well, the last one is whether the systems are remotely managed, and whether like there's a technician who's on site just managing the general scheme of what's going on. It could be that the end users, for the most part, manage the mics themselves, but there's an overseeing eye double checking that everything is functioning precisely as it should for all of those rooms.
Yep. Our third topic of consideration is the application or the use of the mics. How is your space being used on a day-to-day basis? What type of meetings are you having? And is it a flexible space where people just gather around a table, or even, in some spaces now we don't have tables, it's just bean bags that you can go and kind of lounge around on and share.
Oh, they sound relaxing.
Yeah, can share kind of creative ideas. You may have a slightly more formalized training environment where every person has their own desk to sit at and the lecturer has a podium to present from. You might have a meeting room, which is more like your kind of traditional boardroom situation, where you've got a VC system at the front with a camera and a display, and then participants sat around a table. So it's kind of fixed furniture, but maybe you have 4 people in there one day, you have 8 people in there the next. And finally, what about a mission critical situation? What about when you're building a facility for your CEO to broadcast onto a news channel? Maybe you might want to look at something that's a little more robust for that space than you might for your flexible space.
There's quite a range there, isn't there? You've got literally, like, say we were in 2 different office buildings, had a wireless mic in front of us each. And you know what? If my wireless mic doesn't happen to work on a given day for whatever reason, it doesn't matter that much because I'm only having a daily catch up with you. But equally, a wireless microphone could be the CEO of a company broadcasting to all of their sites in one country and well as multiple countries as well for an internal audience or in fact an external audience. So that's basically TV, isn't it? And live TV, and you really want to make sure that functioned properly.
Correct. So yes, really understanding what type of situation you're using your mics in will help guide in your product choice.
Cool. And lastly, we have the fun one, which Andrew's largely covered already, but our transmitter type. First, we have our, our combination of handhelds, headsets, boundaries, and lastly, gooseneck microphones. And all of them have pros and cons depending on how you're using them on a given day. So handhelds are just great. You just pick them up and you hold them, but you do need to have some degree of microphone technique because otherwise it might go really quiet and they're really loud and bassy if you're not great, or people just held them further and further away from themselves because they hate being heard. But it's great because you can just easily hand it to the next person. Of course, not so much right now because of COVID, but in the future, that will be very much possible. Headset and lapel microphones, that's the ones that we're using today. There's a little lapel mic here. Quick scratch for you, and I've got a body pack in my pocket round here. So the microphone sections goes into the transmitter and then transmitting wirelessly and magically to our receivers in the corner of the room somewhere.
And I have the same system here. So it's 2 wireless mic channels. We've got the same mic capsule, the same body pack, and so it should sound tonally very similar to you guys at the end.
So all you should hear is the difference in my voice versus Andrew's voice because they natively are good quality, clean systems. And the good thing is that this microphone always stays a consistent distance. So wherever I go in the room, the microphone level should remain the same. A headset goes a smidge further because it literally turns with you as you move your head up and down as well. My beard can get in the way slightly. Here's a few little ruffles, hence the need for lapel microphones today. A boundary microphone is a small microphone that would sit in front of you on the table. So it doesn't have the large gooseneck popping out the top, but literally sits very, very small and low profile. So we could, for argument's sake, have one microphone here between the 2 of us. That would end up for a bit more of a spacious sound. You're listening to me quite close mic'd now, but it would sound a bit more natural with a microphone on the table between 2 talkers.
But if you put that microphone in a very reverberant room, it's got big wooden table, marble floor, glass walls, it's going to pick up a lot of reflected sound and it probably won't sound fantastic.
That is indeed true. And lastly, we have the gooseneck microphones. They look a bit like a boundary, but just with a stick on top of it to get you the microphone capsule much closer to the talker. You'll have seen them on TV and lots and lots of meetings.
They're like your halfway house between the boundary and your lapel, aren't they?
Yeah, I'd agree so. But again, to address those properly, you ideally would have some degree of knowledge of, I need to stay approximately this distance from the gooseneck. Otherwise, it could go really bassy or go really, really quiet, for example. But I think just to kind of surmise on this slide here, if you could answer all of these or give an answer to how you want to use these microphones in all of these ways, it will give you the informed decision to help you determine which wireless microphone system is going to be the best one for you in a given environment. And don't forget as well, you might find that for your whole facility, a combination of some of those systems there, some of those there, and lastly, some of these ones here might be the best spread.
Yeah, I think it's fair to say there is no one product fits all in terms of wireless mics.
Which I think is why people often find it a little bit tricky to figure out because, well, that's wireless and got some good features, as has that and as has that. But they're just a bit good at sort of nudging ahead of each other in a given example.
So now we can think about how we want to use the mics, the type of rooms that we want to use them in, the kind of transmitter form factor. We can start doing our spec sheet comparisons and looking at product. And finally, are these going to work? So I found my microphone, I found what I've got to use, how I want to use it, where I want to use it. How am I going to know that it's going to work? Well, this is where we need to start looking at the spectrum in a little more detail.
It's a bit like, I've found the sofa I want to buy.
Yeah.
Will it fit in my room?
Yep, exactly. And again, there's some considerations to think about. So how busy is the RF spectrum? Where will I have space to operate within the spectrum that's available? How many channels can I expect to work reliably? And what outside of my microphones might interfere with my RF systems? So we can do some scanning of all these different UHF bands, but for the purpose of this bit of topic of conversation, we'll just narrow our focus to the UHF band, but the same principles apply to anywhere that you want to run radio microphones. You need to run a spectrum survey.
So just because the UHF spectrum is a little bit of the words is the most complicated one to figure out. So the UHF spectrum, or block rather, at large is split into these individual chunks, if you like. Each of these is 8 megahertz wide. And each chunk of these is assigned a channel number. You heard Andrew mention channel 70 earlier.
Yep.
That is, well, the bottom quarter of one of the chunks of the UHF spectrum. Here it is split into block form. So you can see on our chart here, we've got TV channel in the top row, running from 21 through to 49, because that's the currently legally available space we have in most of Europe. That covers the overall frequency range of 470 in that top left grey box.
TV channel 21.
That's right, up to 702. So each of that whole chunk of spectrum is split up into, about 30 or so contiguous 8 megahertz blocks of spectrum, and each of those is called a TV channel.
Yep.
So the way I like to think about this is think of the UHF band as large as a large car park, and each of the TV channels within that car park is like a car parking space. Now, when you purchase or rent or use a car park space, you can either put one car in it, or you might be able to put 5 motorbikes, 15 unicycles,
Yep.
or half a boat.
Yep.
So the spectrum is there, and it's a given amount of space, and what you put in it, i.e. your channels of microphones, depends on the quality of the system or just what you're doing, basically.
Yep.
So in order to figure out what TV channels or which car parking spaces are available in your location, you need to do some kind of spectrum planning.
Yeah.
This is an example from the UK, as that's the country that both Andrew and I reside in. So this is again from the Ofcom website, and all you have to do is type in the location of where you are. I've just chosen Alexandra Palace, an old TV broadcast place in North London, not far from where I live. So this is what the spectrum looks like in this area. And once you press go, it gives you a chart that looks a bit like this. So down the left-hand side of the chart, you can see the TV channel going from high down to low. The middle column is internal frequencies and quality, and the right-hand column is external frequencies.
This is like a radio mic's dream, this, isn't it, really?
Absolutely.
Lots of blue, lots of green.
The reason we segregate the two is because when you're outside, because the main bit of spectrum that we share the UHF stuff with is TV broadcast. And much like when you take your mobile phone into a big shopping centre or in a big multi-storey car park, the signal on your phone is much lower. It's harder to get 4G in there, which is precisely the same that happens here.
Yep.
So if a TV broadcast which shares this spectrum with us is broadcasting in London, it means that the spectrum that we'd want to use outside would be less available whilst outside. But when you come indoors, generally speaking, you'll be somewhat shielded from that that radiation rather, which means the spectrum becomes better available for you.
Yep.
Blah. So you'll see here TV channel 60 is nice and clear for both inside and outside. TV channel 56 though, it says external frequencies on the right hand side, it's not available. There would be a strong TV broadcast outside somewhere. However, by the time you go inside, you might just about have some spectrum available to you, but it's not ideal because we know more green bars means better life.
Yep.
And down the bottom of the chart, you can see it gets a bit busier. So there's more TV broadcast in the 21 through 32 range in London there is in the higher bands. So that gives you an idea of which system you might be able to do once we give you some more tech details.
So if you were looking to put a radio microphone system in this location, you would definitely want one that could tune to the higher frequencies.
That's right. That's right. And while we're focused on the UK here now, we have similar websites for other countries as well. Here you can see, here's the French one. Again, the chart in the middle, or the panel in the middle rather, shows you quite clearly that a lot of the UHF spectrum is now assigned directly to 4G telecom. And then you can see the availability and strength levels of radio microphones in the other TV channels for the same range that we saw for the UK. Equally, you have a similar one for Spain, which shows you for a given TV channel what is broadcasting. So a different approach, but you similarly
get the end results the same.
Yeah, what can I use? What can I not use? And a similar one for the PTS service over in Sweden, where for a given grid reference, it will tell you at the bottom of the screen, you can see available channels. So K22 or channel 22 would be available, as well as 25 through 26. You get the idea. So in fact, every country will have a website resource that you can go to figure out which are the bits you should use.
It's really the same data, just presented in a different way.
Correct.
So once you've looked at your regulatory body to find out which of this spectrum is available, you can then look at more specific detail in your actual location. What is there in terms of noise, and how clean is the spectrum that I'm looking at? If you already own a Shure receiver, you can use that to run a scan. With a bit of our software called Wireless Workbench, you can take your receiver and it can monitor the environment in which it's sitting and print you out a nice little graph. If you don't already own a Shure receiver, you could contact an authorized integrator. Maybe they could loan one to you or source one from their distribution channel. If either of those two failed, you could speak to your local Shure distributor. And there are some very skilled, very professional third-party skilled people who can do this RF coordination for you as well if you want to hire in some external help. And what those systems and those skill sets can do is provide you with a graph that looks like this. So this is taken from one of our dedicated spectrum scanners, I believe, the Axient Digital Spectrum Manager, and it's scanning from the very low end of the frequency right up to the top.
So I can see on the bottom of the graph, we've got TV channel 21. It's listed very small.
Yes, on the left-hand side, we've got TV channel 21.
And on the top right, we've got up to TV channel 70, then a gap and some stuff in spectrum we don't use in the UK. So you can see how those contiguous TV channels are represented here.
Yeah, and again, this is very, very clean noise floor. So this is probably similar to what you would expect to see in the Alexandra Palace scan indoors.
Yeah.
This, on the other hand, is a slightly less optimal looking RF scan, because all that data is higher up the graph, which means there is more RF energy in and around your environment. So more of that is hitting your RF receiver, which is going to make receiving your dedicated transmitter a little more difficult. So the noise floor is how much of this RF energy is just present in the atmosphere where you're trying to use your radio mics.
It's a bit like me turning the radio on right now and having you try to talk over it.
Yes, exactly.
They're both taking up the same space.
Yeah. And this is a dirty noise floor, which would make running microphones a little more challenging. And here we can see an output from our MXW wireless system, which is scanning in the decked range. So the output here is represented slightly differently, but it's shown here. Green pi means good, red pi means bad. And the bigger the green pi, the more microphones you're going to be able to operate at the same time at a reliable quality. So maybe a simplified graph, but ultimately, yeah, it's doing the same job.
Yes. So let's have a look at which of the Shure wireless systems you could choose. Again, we've chosen 3 examples here today, but the list is not exhaustive for these 3. So we have got MXW to look at. We've got ULXD, which is the one we're using today, incidentally, and we also have Axient Digital. Again, all 3 flavors of wireless microphones that are appropriate to the corporate workplace.
Yep.
But just which one you use would depend on the precise set of features that suits you best.
And by navigating that matrix of questions that you're going to ask yourself when you're deciding which is the best to use.
Absolutely. So let's look first at the Microflex wireless system. You can see some of those gooseneck transmitters on the desk there in front of them. So this is a system that runs in the DECT range, so the automated pie chart that you just saw Andrew show just there. It's designed for specifically conference-minded applications, i.e. like boardrooms, conference rooms, meeting rooms, and it's very end-user friendly because it has a large degree of self-setup involved. Once you've synced it up, it just finds the frequency for itself automatically in the background. As I mentioned, it's got advanced remote management, so very, very good at being quite hands-off in terms of the way you set it up directly. Like I said, also self-managed too, which is very clever. When I first learned how it actually functions, like, that's pretty smart.
Yeah, I think the technicalities of it are slightly out of scope, but the way it works and manages itself is very impressive.
Agreed. It also means because it uses or shares some spectrum, we get a pretty high channel count. What's the channel count for the UK?
100 in perfect conditions. I think it's 120 systems thereabouts, or maybe even slightly more.
So 120 systems, 120 channels in one location.
Yep.
If you go far enough away, so you're not hearing that other RF space, yep, you can then get another more and 120 more channels as well. So that's pretty cool. We have, in terms of the components, or the receiver rather, we've got a 2, 4, or 8 channel system. And lastly, it's always encrypted, which is very, very useful indeed. This is what the components look like. There's the MXW1 body pack. It's got a built-in microphone as well, so you don't even have to plug a mic like this lapel mic into it directly. You also have the MXW2 handheld microphone, and like Andrew said at the start, you can unscrew the capsule for your preferred microphone sound on the top end if you wanted to. We also have the MXW6 boundary microphone, as well as the MXW8 gooseneck microphone, and you can change that gooseneck in its length as well, so depending on how direct you want that microphone to be.
Short, medium, and long.
Correct. That's our access point behind us, as well as the network charging stations too. And this all runs off a single network switch of some type, basically. You can actually see it behind me on the top left here. So there's our MXW1 body pack, the handheld, the boundary, and lastly the gooseneck. And it's sitting in the charger, and this is the access point. So this is what would sit up in the top corner of the room somewhere, fairly unobtrusive with some little lights on, and it comes with a paintable cover as well. So you can even match your decor if you wanted to. It's also got a very, very cool feature built into it called remote linking. So because typically with a system, once you've set it up, until you start to press some buttons on it, those channels will talk to each other at all times. But you might be in a situation where in our office building here, we have wireless in this room, in this room, in this room, and in this room here. But we don't necessarily want to buy all the transmitters for all the rooms at all times, because one, they're never all going to be used at the same time. So if we can manage them more smartly, that'd be pretty cool.
So this comes under your, how many do I need? How many do I need at once?
Actually need, yeah. So this could be our reception area over here, and reception is where we manage the wireless microphones. There we have our little network charging station. And say we want a pair of microphones to be used in one of the rooms. They get placed in the charger, and then you can press some buttons on a control panel, which there are external control nerdy strings for, which means that those microphones at the touch of a button are automatically paired. It should be an animation. There we go, to one of the particular rooms without actually formally doing it in that room. It means we could also take a pair of different transmitters and have them to be remotely linked to a different room, for example. So there's lots of different ways to do this.
Yeah.
Let's look at some of the benefits of DECT generally. We talked about spectrum earlier today, and the positives of DECT is that it's license exempt globally. There are different bands for different regions of the world, but the EMEA region, they all use the same DECT band. It's automatic frequency coordination, so you don't have to learn how to use weird software.
So when you link that mic to the transmitter, it's a data link between the two, and then between the system it figures out which is the best frequency for it to operate on. It's
akin to pairing a Bluetooth device with a different device. Then once they're linked, they just magically do their thing for you. Hence avoiding interference, and because it's self-managing as well, you can get some pretty large channel counts there if you needed to. On the gentle negative side, there is a degree of data compression, not that you hear it at all, and the channel count we use, depending on the codec, is a high density mode, which means you can get even more on air if you want to. We've put the word latency there because to the nerdy audio folks, which we all are, there is a degree of latency in here. However, for the application where they're often used, namely video conference and broadcast, not professional broadcast, but video conference rooms, the amount of latency in the system is perfectly appropriate for what they're being used for. The DECT is shared with other users as well, like the DECT phones, so watch out for that. And compared to a UHF system, which you might see used at like a big festival or something like that, these microphones have a relatively small range. But if you're in a boardroom of an average size, you're not really going to be needing to transmit more than 5 or 8 meters maximum. So it's about thinking about how you're actually going to use this microphone.
In the maximum power output mode, I think we can go up to 30 meters line of sight. So short is still relatively long. Like a 30-meter long boardroom is going to be a very long boardroom indeed.
Yeah, definitely.
But yes, if you're putting it in your typical up to 20-person space, that is a short operating range.
Great.
So by comparison, well, let's have a little look at our ULX-D system. I think you'll notice some similarities here, but there are one real big difference as well. So ULX-D by comparison works in the UHF band. So this is not DECT, this is your lower down and is therefore licensable.
With all the car park spaces.
Yeah, so whereas MXW was free to use, if you're using UHF, ULX-D, you will need to have some consideration of a license.
Particularly in the UK.
Yes.
Yeah.
It's been designed for medium and large rooms, so higher body count, so a larger audience. It does have Dante digital audio on it, so if you're integrating it into a sound system or a DSP or a conferencing application that can receive a direct digital Dante feed, we can do that straight off the receiver.
MXW had that as well, incidentally, but this wasn't on the slide.
It is easy to use. It's got the rechargeable batteries, so once it's all set up, your user can take the transmitter out of the charging station, turn it on, and it's working. There's no mute buttons on there that you get kind of caught up with. It's on, is it on mute, is it not mute, is it off? It's on and working. So it is actually very easy to use. You can remotely monitor the system, be it the battery health or the RF strength and quality. And
the audio.
And the audio, of course, yep. And same as MXW, you can get a very high channel count, but it does need some much more manual coordination and choosing and plotting those channels. It's not as simple as turn it on, link it up, and it's working. The audio is encrypted, which we spoke about before, and it's a truly professional grade digital wireless system because we're passing 20K to 20 Hertz at the high and low end of the frequency range. It's got very low latency in the, was it 4 milliseconds?
I think maximum is up to 4, yeah.
And a very wide dynamic range as well, so you can do a lot of very high quality, high fidelity audio over your wireless.
So the takeaway from that is it just sounds natural. It doesn't do anything to your voice. It just sounds exactly as you sound.
What goes in comes out.
Gotcha.
And the component list is very, very similar to our MXW. So we have a ULX-D1 body pack, we've got a 2 handheld, we've got a 6 boundary, we've got an 8 gooseneck, we have some receivers here, slightly different. We've got a single channel, a dual channel, and a quad channel. One point of difference really, other than the channel count, is the single channel receiver does not have a Dante chip in it. So if you're looking to integrate MXW into a Dante network, you will need a dual or a quad receiver. Other than that, all the functionality is the same. And we have some chargers. We got any of those on the table here?
Yeah.
Yes, at the back.
So this is the SBC, what's going to be the 450 because it's got 4 bays. And in it you can see I've got the gooseneck microphone, which just comes out ready to use, and the same with a boundary microphone as well. So it's very easy to pop back in their chargers.
Nice. And from an operational point of view, it's the same as MXW. You take it off the charger, it's on, it's passing audio.
Yep. And the chargers are all remote controlled as well.
Yeah, of course.
So they can be on the network so that your person up in the operatory tech room can have visibility of the audio kit and the charging status to know that, it's 6 o'clock on a Tuesday, everything is on charge, which means it's going to be running properly on Wednesday morning rather than oh no, the battery is flat, because we don't want that to happen.
And so next, Tom, talk us through Axient Digital, which is slightly higher up the product range to ULXD, but by no means that ULXD is poor.
Yeah, exactly. It's like the bigger brother of ULXD here. Axient Digital really is our high top-end broadcast wireless microphone system. It's the one that gets used on all the festivals, all the rock and roll shows, all the TV shows as well, and a lot in the theatre land that we have here in the UK and America and Europe as well. And people choose it because it just is that much more resilient than ULXD, only by a notch, but a notch enough to make sure that in those really tricky RF environments, you've got a rock solid, absolutely stable channel counter system.
Your critical performance.
Yeah. Yeah, but that doesn't mean you can't and shouldn't use it at those lower tier things as well.
Nope.
If you need to. So designed for, as we mentioned, mission critical applications. And of all of the systems, it has the widest tuning bandwidth. I'm just going to cover that in a second, what that actually means. We also have the ability to set up some automatic backup frequencies. So a bit unlike MXW, which just does itself new frequencies in the background. This one's a bit more manual, but you have got the capability of coordinating fresh backup frequencies, which can be monitored so that if there is interference on a wireless mic channel and it drops out, you can automatically deploy a new frequency to it and it's up and running again. It's a bit like trying to push a beach ball underwater with one hand. It's just always going to pop up again. Of course, we have the ability to remote control and monitor the Axient Digital system too. And we've unsurprisingly have a very large channel count as well. You can stack these frequencies really close together. My PC's just had a bit of a confusion just then. Let me see if we can get back to share that. Am I still sharing the presentation? Yep. Good.
There we go.
Good. Cool. And being digital, of course, we can still encrypt that signal too. And it is really our premium grade digital wireless system. It's the absolute flagship of all we produce here from the world of Shure.
Yep.
And it has, of course, the Dante outputs as well, which is the one you're most likely to use, as well as the flavor of AES-67.2 and some AES-3 digital outputs if you're using it into a broadcast system as well. An incredibly low latency too, which is only 2 milliseconds.
Yeah.
But for a spoken word application, that's not going to be critical in this environment. It's more critical for the song and dance routines. So the components are as follows. We have the AD1 body pack and AD2 handheld, the standard body pack handheld combos we've seen before. We have two receiver flavors. We have the dual channel and the 4-channel, all in a one rack U space. We also have a charging system. You can see them in this little space behind me right here, so we can recharge the batteries with the system straight away. This is the Spectrum Manager. This is the device that can help coordinate frequencies and then prepare backup frequencies for you too. But if you want to actually deploy those backup frequencies to your transmitters, you will need the little ShowLink device, a 2.4 gigahertz control device basically, and you need to upgrade to those ADX transmitters. So it's kind of two systems within a system. You've got the standard AD rock solid RF capabilities of the ADs, but then the ADX components on top, which allow you to allow themselves to be controlled remotely.
So this is really nice if you're building a system where you would have, say, 8 body pack transmitters, but 2 of those are for the chief guys in the presentation. So your 6 panelists may be okay, not ideal if they experience dropout or RF issues, but you've got 2 people who really can't. So you can invest in the receivers, 6 AD1 body packs for the people who are not VIPs, and then the VVIPs get your ADX transmitters, your ShowLink access point, and the Spectrum Manager.
I think our American colleagues call them the money mics.
Money.
So benefits of AD versus ULXD. Oh, you want to take this bit?
Yep, a wider tuning bandwidth. So we've talked about frequencies and TV bands and your car park. So this is really how many spaces could you operate how many parking spaces could you take up with your Axient digital receiver? It's like taking a bus and parking it sideways across 15 spaces.
I've done it so many times on my bus.
Which does actually have some benefits because you can procure hardware for different regions with just one piece of kit rather than having to worry about, oh, well, I have to have this variant of ULXD in this territory and this variant in this territory. You could just buy one unified platform across the globe, which means you have common components across an estate, which obviously means easier maintenance with less spares, because if you've got UHF for ULXD in the lower tuning range and the upper tuning range, you can't share transmitters across those receivers. And from the naked eye and a casual look, it's very difficult to see which one's tuned to which. So you've got to be a bit more careful around keeping spares for a particular territory or location, or even if you're in a situation where you've got poor RF availability, you might need some at different ends of the spectrum to get the channel count that you're looking for. So this is an advantage of Axient Digital over other systems. And because of its rock solid RF modulation scheme, it is giving you a bit of future proofing around extra use in that spectrum. And because we've talked about the two-tier design, it means you can look at building a system that is good for the most people and then having your VIPs with a little extra technology and resiliency on top of that.
The icing on the cake.
Yeah. So from a graphical point of view, here's some spectrum for London. It's in a different place to Alexandra Palace. I can't remember exactly where it is. But we can see that actually in the upper bit in your ULXD K51 there, that's not great for radio mics. So you would not want to think about buying ULXD in K51 to operate.
So K51, that represents numerically, or from a Shure numeric, a range of spectrum,
yes,
on which it operates.
Yeah, so K51 can operate in TV bands 45 through 39, is that? It's very tiny on my screen. But you can see on your graphic there, there's very little usable, in fact, no usable spectrum outside for that system. So if you're looking to buy something, that would be a poor choice
for this location.
However, ULXD in H51 is looking pretty good. And equally, your G51 is looking somewhere in the middle. So if you were looking to buy a system in this location and you were looking for ULXD, then H51 for those tuning TV channels is really the one of choice. However, if you were to buy your Axient Digital system, you could just tune it to operate in the frequencies within that little band. Now that's interesting for London, but let's also look at our next slide, which is Bristol. Bristol is a lot more difficult in using radio mics because that's where a lot of TV broadcast comes from, and they've got some very high-powered transmitters over there. So here, using your ULXD in G51, which was okay for the previous location, is now useless in Bristol. Similarly for K51. So if you're using ULXD, you've got to have H51 for Bristol, but you might want G51 for London, but you could just buy Axient Digital and use it in both.
To be clear, this is a kind of worst of the worst case scenario.
Oh yeah, this is one of the worst places in the country to try and use radio mics.
Just want to calm you all down a little bit.
Yes. That being said, though, your Axient Digital in TV channel 31 can operate 64 channels all at once. So there's still an availability to run a lot of radio mics in that tiny bit of section.
Yeah, cool. Right, let's start to sum these guys up. So I'll quickly read through these. So in terms of the feature sets, we've got a self-managed wireless. Only MXW can do that. The other systems require, particularly ULXD, require a bit more setup. All three can be remotely networked managed. All three have Dante. All three have wireless encryption, which is pretty handy. Only Axient Digital does not have the gooseneck or boundary option. All three have network charging stations with a fully rechargeable system. And rechargeable systems, firstly, it's good for the environment. And secondly, it's just easier for your workflow as well to not go, oh, we're out of batteries again.
And cost effective in the long run.
Correct. And for the UK in particular, only MXW is license free. The other two would require a license here in the UK. There's a nerdy feature which means you can, for MXW, which means you can feed a channel of audio back to the transmitter, but that doesn't get used too often.
No.
And only ULXD doesn't give you some degree of remote control of the transmitters. So let's have a look at the ideal use for these wireless systems. So in a video conference space, a huddle space of 1 to 4 channels, MXW is going to be your best bet there. And the same is true really for a medium 6 to 8 channel space as well. We don't worry about five-person rooms. They don't exist. A large meeting space of 12 channels or so, you might start to think about using ULXD as well as MXW in those range. When you come to a large multi-room facility with antenna combining and some stuff like that, things like AD would be your best bet for those rooms there. A boardroom, again, depending on whether it's a low-level boardroom or a high-level boardroom, arguably all 3 wireless systems could be appropriate. A reportable VTC or video telecommunications cart, so a system that gets removed or moved rather from room to room, depending on where you want to have an ad hoc meeting. MXW is arguably the easiest system for that. Why? Because you just put that little antenna on a stick, have some microphones remotely for the handhelds and presenters. It manages itself automatically and just works.
Of the 3, it's your most plug and play option.
That's a really good way of describing it. And lastly, for a training room, MXW would be the best situation there. A small to medium multi-purpose room, MXW and ULXD would be appropriate, as for a large multi-purpose room really as well. As you move to the large town hall and company-wide speech, probably moving toward the UHF, bit more rock and roll style, performance style systems would be the ones to towards, like we're using the ULXDs today.
Yeah, I mean, the reason for that is because MXW transmits on that higher end of the spectrum, the radio waves are much shorter and they have less power, which means us as humans absorb the radio frequencies of MXW much more than you do with your ULXD or your Accent Digital. So
yeah, and I think to kind of frame that again, it's not that we wouldn't trust MXW to do it, but we would just put that bit more rock and roll trust in the ULXD and ADs. They're all good, but the UHF ones would be that bit more reliable when it comes to end of range stuff.
Looking for those marginal advantages.
Yeah, and speaking of marginal advantages, all the kind of top end broadcast public announcement things is where you just, do you know what, I'm just going to use Accent Digital and just rely that it will work absolutely fine. So let's look at some case studies.
Yeah, let's kind of take these last 5 minutes of broadcast to look at some customer choices of which microphones they've used for their given application. So here we can see in, where is this? Canada, British Columbia. We've got a multi-channel Microflex wireless system. So here they opted for a number of boundary microphones. You can just see on the table there. I'm not quick enough to count them, but I'm going to guess it's in the region of 24. So 24 microphones, all self-managed, self-wireless. They may not always be using all 24 of them. We can easily see that that furniture is flexible. So one day they might have this big square table layout, and another day they might have their more kind of classroom style rows of seating. And the boundary mics means that they can just take them out of the charger, put them on the table, and it's up and ready to go.
Perfect.
Secondarily here, we've got a presenter at a financial organization. You can see in the background there a podium where they would have traditionally a wired gooseneck mic. But on the table here, we also want to use some of the participants to join in this conversation. Our presenter has a handheld mic. The participants on their little circular tables there have goosenecks. And it just means that everybody's got the form factor they need. I believe, and it might be anecdotal, but the reason they chose ULXD for this space is because they did a spectrum scan and found out that the available spectrum in MXW, which typically might suit this space a little more appropriately, there was just not enough spectrum available in the local area to successfully run a decked system, so they moved over to ULXD and UHF instead.
And I think one reason as well why you've got lots of the participants on a call as well is in this day of remote learning and people dialing in, because I remember like even 5 years ago you would have a meeting only in that room, you would broadcast only to that room. But the trend now, of course, with all the COVID isolation going on, is to make every room bridgeable with lots of other rooms, so you need to hear the presenter and also what's coming from, or the questions from the floor as well, so everyone can participate in the meeting, so not only being in that room.
Yep, absolutely. I think you've got a bit more detail on this particular case study.
Yeah, so this corporate wireless project, but they used the Axiom digital system. It wasn't so much an installed system, but more on, as you can see with the racks on the right-hand side, that's not one large system. Each of those 2U racks, which are about this high, contain one 4-channel receiver and a drawer with some transmitters in. So they can easily deploy a small 4-channel system to multiple small areas in this huge Congress Center in Stockholm. So in the RF environments in those places are usually pretty busy. So just to have do you know what, I'm going to chuck a 4-channel AD system there, and just know and trust it's going to work would be the right system to use in that environment.
Yeah, because 4 channels in a room doesn't sound like lots, but 4 channels in 50 rooms stacks up pretty quickly.
Sure does.
Yeah. And finally here, this is slightly off topic for what we've been talking about immediately today, in that we haven't referenced our Microflex Complete wireless system, but we are seeing a lot of people take interest in this at the moment because of the need to have physical distance between participants. So MXCW also includes a loudspeaker in each transmitter that you can see there.
So if I spoke into my one, my audio would come out of yours.
Yes, and
vice
everybody
versa.
else's.
Gotcha.
So once you start putting a lot of space between people, it becomes quite difficult to have an open flowing conversation. So our Microflex Complete wireless system gives everybody their own microphone, and it's its own self-contained PA system as well as a microphone. So for doing council meetings in spaces which are larger than your council chamber, we've seen them being used in sports halls and kind of school halls, and in here we've obviously got some large government building where they need to have.
So traditionally it would be used pre-COVID, where you'd have one, I'd have one, as with all my neighbours.
Yeah.
To the point where those people over there couldn't hear me acoustically, but my sound is reinforced by the speakers all the way over there. However, in this year rather, it's come into itself because I can literally have mine 2-3 meters plus away from you to make sure that the whole room is socially distanced.
And equally intelligible to each other. So yeah, we thought we'd include that just as a bit of a topical conversation piece.
Gotcha.
So at this point, we will take a look at the questions window, see if anybody's typed anything in there. If you have a question, now would be a very good opportunity to quickly type that in, and we see if we can get to it. So,
I'll try and stop sharing this, so we can just see the cameras.
Yep.
I can remember how to do it.
I cannot see any questions in here at the moment.
Oh, excellent.
So we'll take that. Currently, we don't have anybody who wishes to raise the hand, unless I'm looking in the wrong place.
No, I think we're good. Just give it. So if anyone does have a question, then feel free to type it in. Just going to show you the system we've got in the background here. So on this top shelf here, we've got the Microflex wireless system. This is the APT, the access point transceiver. As you showed you earlier, the network charging system, with its transmitters in place. So on this rack here is the ULXD. So you can see we've got the ULXD 4D for the dual system, and also the quad receiver here. These are some of the transmitters for it, and the rest are in the drawer, tidied away. This is my Axiom digital system. It looks quite similar in general schemes to the ULXD system. These are the dual channel receiver, got 2 channels, and then the 4-channel receiver here. This is the brains of the system, the spectrum manager, the one that can coordinate and then deploy the backup frequencies, and lastly my battery charger here. So the more systems you had, the more physical rack space you'd take up, but they'd typically not be in your pretty boardroom, but kind of hidden somewhat out of the way.
So one point of interest then for Microflex Wireless is there's none of this stuff.
That's true. The system is
taken care of by the white access point transceiver up there.
Apart from the network switch that needs to power it all. Yeah. Gotcha. Well, I still don't see any questions having come in, so I think we can assume that was all good. And well, I hope you guys all found it nicely useful.
Yes.
It's been a pleasure presenting it.
Absolutely. And if anybody does happen to have questions as a follow-up, we will happily take those over email.
Absolutely.
So yeah,
hey guys,
for giving us your attention for the last hour this afternoon, and we'll wish you a good rest of your day.
Thank you very much.